Hello, hello. How are we doing today? Appreciate the kind words, Ben. Definitely enjoy the things that you do as well. So learn from each other, right? So let's see. We are. I think we're gonna dig into Rust caches today, particularly in Github Actions. I think is where it's going to come up. Because Rust can take some time to build, and there's benefits that come out of that, but it means that our CI can run pretty slow. So we want to dig into that a little bit. Ooh, there's a cat. Hi, kitty. Put that tail down. Um. Yes, yes. Now you've distracted me. What was I gonna do now? Oh, yes. Okay. So let's move over the display. I need a bunch of things I need to do today. Power Toys. So I use Power Toys. This is Windows. Use Power Toys to do the window snapping. It works pretty nice. But I forgot to switch it to my stream layout. And I can't remember what my hotkey is. So there we go. Okay. So we want to look at Rust caches today, particularly in Github Actions. Locally, when you're running things, once you build once, if you have the incremental mode turned on, it works pretty well. So this is more going to pertain to when we're running in CI. Kitty. All right, so there's two packages. Is Cargo Chef, I think? Yes, Cargo Chef is the one that I want to look at. I think it's called Rust Cache. Um, it doesn't look like the right one I'm thinking of. See if we can grab a quick. I know we were talking about it in the Discord, in the Tauri Discord, that is. Yes, Rust Cache. So I think these are going to be the two that we talk about today, or we look into today. We'll probably throw a bunch of stuff in a new GitHub repo just to test it out and see how it works. The things that we're mostly focusing on, I think, are going to be caching that target directory. And one thing that's interesting with this, and the reason it's worth diving into a little bit, is that when you're caching Rust, those build folders can get pretty big. So you'll have a target directory when you build something in Rust, and you have a repo limit of 10 gigabytes. That can get blown up pretty quickly, especially in larger Rust projects like Tauri. So when you pull down a Tauri project, you're bringing all those dependencies with. And since we're at a repo level, since that limit is at a repo level, we're going to hit that relatively quickly. 2 PRs and then a cache on the main branch. We're going to hit it pretty quickly. So there's some things that we can think about as far as sharing the caches between PRs and the main branch. And these are going to be the things that I think we're mostly looking at. The registry cache and index. That will help us skip downloading the Rust crates. I don't remember what the cargo git folder does offhand. This target would hold our incremental compilations. So it'd be nice to cache that if we can. I don't know if though we're going to be able to without blowing out our cache. And most of these have some indication on actual cache hits, or it'll say it in the output. So that's how we'll know if we're hitting cache or not. And the other one is, so there's Rust cache, which is a general Rust caching. It is sort of built to only work with one target directory, which is going to work for most Rust projects. If you have more than one workspace, or you have some polyrepo kind of stuff going on, that's going to be less likely to be valuable because you might have multiple target directories. The other interest that I have to use this is we actually just I just spun this off the other day. We have for Tauri, we have a create-tauri-app. If I can spell, here we go. We have this in the main repo, but the security guarantees and the way we're doing versioning with this tends to diverge from how you're thinking about things in the main repo. The general expectation with these are that when you run it, you're always getting the latest dependencies. So this tends to be more of a roll forward kind of thing. Anytime there's a change, we want to be able to anytime there's a change in the dependencies or the things that we're generating, we want to be able to roll forward quickly and adapt to that and push a change out, which is different than how we need to think about the main Tauri dependencies. And what gets interesting with this is when we start thinking about testing this, we have many permutations. I wonder if we can pull up an old Github Actions run for one of these. I don't know if we'll have it. But we can spin up a lot of boxes real fast, which is nice for like really throwing some tests at the things we are concerned about. Let's see it. What did I name it? Run core, smoke. It's not this, is it? Yes, it is. Yeah, so we can spin up a lot of boxes here to test real quick, which I think is pretty, like this can be handy. But we start to hit limits there. We can't see the runs. But it would be nice to share some of that cache between them, because mostly what we're doing here, the compilation of the dependencies should be pretty shareable. The thing that isn't is the code that we're pulling in when we run like create-tauri-app, because that brings in a bunch of front end code, and then like the main.rs that is effectively your app, and those are fine to compile. If we can pull in the incremental compilation from all of the dependencies and we're only compiling your main.rs, that'll go a lot faster. So that's kind of how we're thinking about stuff. And if you have just a Tauri project, this Rust cache is probably going to be sufficient. From what we've looked into it, I think the big thing is that you'd have to change the target dir, because by default, when you run a Tauri project, you have an src Tauri folder, and that's where your target gets dropped. Any questions about that? Have you all gotten into Rust at all? Dug into that language? So the other one that we were looking at is a package called cargo chef. It's a cargo subcommand. So you can, when you have the cargo command line, you can add subcommands. Where does it list common ones? List installed commands. Okay, so I think this is all of them. Let's make that a little bit bigger. So I think one that I have added is called cargo add, I think. Actually doesn't give any mention of it. It looks like I still have some old Tauri things sitting around. I could probably delete those because we don't generally use those anymore. So when you do this cargo install, it's adding a subcommand, and it's sort of like a global command for cargo now. And what this subcommand then does is enable these two sub commands, right? Those are called commands. I guess it just says commands. So from this command that we've installed called chef, we now have cook and prepare. And the idea here is that it's primarily to speed up container builds. I think the intention originally is Docker files. So within Docker, you can run a compilation that just includes your dependencies, cache that in a layer, and that step will be automatically pulled from cache if nothing's changed, which is mostly going to be that. So if nothing's changed there, when you run cargo chef prepare, then this whole step will pull from cache instead, which should save you a bunch of time. I think we can still potentially use this though. And we'll just have to see how it deals with target directories and such. But the fact that it's actually outputting a JSON file, that might be something that we can use. I think what ends up happening is I think what's happening is that it's using prepare to create this recipe.json, which is like a dependency list. And then when you cook, you're only building the things that are necessary or that are listed in that output. So if you're familiar with how Docker works, this is a build stages, that's the word. Docker build stages. So every time it calls a from, this is like a new build stage layer. And so the first build stage, or the first stage in this, is pulling this image. And then from that image, it runs cargo chef prepare. And then this is a thing that gets cached. So next time when it comes around, and it's copying the whole directory. That directory gets cached as long as stuff doesn't change there, I think. Actually, I don't know if there's really any caching that would happen here. because this is likely always going to change. So you're always going to copy all the stuff, and you're going to run this every time. But I'm presuming that this runs rather quickly. And this is likely an image that has Cargo Chef installed already with whatever Rust. I guess this their example uses 1.53. So like most of the work actually happens here. So it's pulling from the previous build stage, that JSON file that represents our dependencies. And if this copy has changed, it will basically like rerun this step. And if it has changed, it'll rerun this. If it hasn't, then it'll just pull it from the cache. I mean, this is going to be building just the dependencies, and after that's done, it'll drop that in this layer here, which will be the thing that gets pulled if this hasn't changed the next time you run it again. And then after they do all that, then they build the actual release, and they get their final image. And their final image is much smaller image, I'm presuming, without the necessary build dependencies, and all it's doing is copying that release binary that we created. So I think we can use a very similar process. We can have potentially a step that runs up front. But I'm not sure where the like. So it's basically using this as a way to bust the cache or not. And that cache is going to be, I'm guessing, the target directory. So the downside with this is we're going to need to install this command in our CI run. We are going to need to, okay, there is a pre-built Docker image, which is kind of nifty. So we could potentially run our first step through the Docker image. So GitHub Actions can run Docker images, or it can run just like their built-in runner. So it would be Ubuntu latest, or Ubuntu, Mac, or Windows at their various version tags. You must use the same Rust version for all stages. That makes sense. So we may not get a completely clean cache, but that's fine. I think, so if we use this, it's going to require us to do our own caching. And it seems like we could potentially use them together. Like this is just going to tell us when we should bust our cache or not, which is something that we can feed into this via the key. And there's the shared key. So like that's a potential. I don't think it actually shares cache between PRs. So like we're gonna be kind of SOL on that. Hey Chris, how are you doing? So I think, how do we want to attack this? See, the problem with this And the reason that we can't use it more wholesale in all of the specific Tauri projects. Getting out of the salsa maintainer stuff meeting. Nice. How was that? There was one of these. Oh, actually, I think I still have it up. No, I don't. Do I have it in my? Yes. Issue 24. So you want to be able to specify multiple targeters, which would have multiple, um, which we could potentially use when we're building a bunch of stuff with like create-tauri-app. Good. We covered basically the whole algo and the lib up to this point. Nice. Yeah, that'll be cool. Is Salsa a large code base? I haven't actually looked at it. So for those, Rust cache is for caching Rust. Not terribly large. That's good. Um, Salsa, for those who are unaware, is the what's the best pitch for it? The thing that acts as the database for the incremental compilations in Rust, but it's general enough that it can be used outside of just the Rust compiler. Is that a good pitch? So what we're looking at is ways we can cache Rust in our builds. Rust Analyzer. Is it used in the actual Rust compiler too? I thought it was used in the Rust compiler too. Or am I misremembering there? Not in Rust C. Okay. Is it used in something else too? I thought it was more than just Rust Analyzer. I thought there was a couple things it was used in. Okay. Both query-based incremental computation system. Chalk and stuff. And some other things. Okay. All right. Sounds like I'm just conflating things. So to answer your previous question, Rust cache is a specifically a GitHub action that, given a bunch of keys, it does some cache stuff for you. We've set up the official GitHub cache action, but it doesn't seem to work great. And some of the things that this does that's interesting over just using like direct caching is, I mean, it deals a little bit with a couple bugs that are floating around, but where does it say it? It only caches the dependencies of create. So it does some cleaning. And that's a thing that's interesting about it. And this cargo chef is a thing. It's a cargo subcommand or cargo command that does similar things. And it was originally added, like I think the general intention is to use it with Dockerfile, but I think we can use it in GitHub Actions too. Rust cache over SC cache because Rust cache only does the dependencies. And there's a SC cache action, right? This is probably the... Does this do everything within it? I think that's one of the differences. C wrapper. It's kind of cool that it actually. I didn't realize it supported a bunch of things. I think SC. So there's there's a couple things that we're thinking about. There's the repo limits. Yeah. There's the repo limits. So when target dirs get large, it's harder to just rely on the cache in GitHub Actions directly. And yeah, so the SC cache remote artifacts is real interesting, and that's sort of the out if you're having to deal with hitting that limit. And that's fine for large projects. So like that is something that is an option for like using within Tari directly. But having to set up all the remote artifacts and whatnot for this Tari project is it isn't always worth the effort. And if there's something that's easier onboarding, built more directly into GitHub Actions, that would be nice. And then it would be nice to share some of that cache between not only runs within a PR but also between branches and whatnot. I think we're going to hit some limits on actual GitHub Actions itself because it doesn't let that cache talk across PRs, I believe. But we can play around with that a little bit. So like in general, SC cache is not off the table. It's still useful, but the type of compilation that we're doing within Tari and a Tari project might use, if we can do something where we caching the dependencies and just rebuilding the user code every time, that's probably going to be more beneficial to them, especially if they don't need to set up remote artifacts. The remote artifacts is interesting because it kind of works around the this, I guess it's sort of a security built into GitHub Actions that prevent you to share cache between like PRs. But then it also means you need to think about that yourself. So trade-offs, always trade-offs, right? I'm tempted to try Cargo Chef first, but the problem is it doesn't have any of the actual cache part built into it. So we could do a couple runs using the Rust cache action directly. And maybe that's the easiest way to spin something up. We can spin up a Tari app because that'll take a little bit of time. Get a quick GitHub action going, see how the Rust cache works. Not being able to do multiple target dirs is frustrating. And it's nice that this does only cache the dependencies, but if we're using Cargo Chef and Cook is only building those dependencies anyways, I don't think we need to rely on the cleaning from here. So like, I think this one is probably an easy win if you have a Tari app and that's it, or if you have just a single workspace and that's it, because you have one target dir to deal with. It does this where it's only caching the dependencies. So like I think that there's value there. but I don't know that it's something that we want to use in larger and more complex Rust projects, which is where I'm personally curious more about the cargo chef. So let's spin something up real quick. Guess we'll do just make a repo real quick. We are going to just throw a bunch of stuff at it. Should we just go simple? Rust cache. Sure. So I guess we just it's probably easiest just to generate a Tauri app. npm init create Tauri at latest. I think we'll just run with the vanilla build. Keep that side of it simple. Try that again. So we could do the Rust cache will be actually let's do Rust cache right away. We can see that running. Vanilla.js is fine. Sure. Actually, I'm not sure how that API will be pulled in. We'll find out. So it's cp Tauri resolves to directory. Thanks. Don't do copy enough. Does it not give us a... Oh, I guess there's a dist. Okay, so we want the dist. Just do this. Okay, so we have a Tauri app. Dist is holding our index, which is a rather simple HTML file. Not much for node modules. For the most part, just the API. And our cargo toml is going to have generally Tauri, but that'll bring a bunch of dependencies with it. So if we would run a Tauri dev, I guess we should see it build a bunch of stuff. So what we had mentioned before was this Rust cache is caching this. So our first step here is the download. These first ones will be, it'll cache the download and save those, and the targeter is going to save the compilation of just the dependencies. So I think for the most part, we effectively can drop this in. Profile minimal, that's probably fine. Be nice if they gave us a little bit more here to work with, but Github Actions, go in a .github folder. in a workflows folder in the .github directory. This needs to be in a testing cache. See how well I remember this offhand. Job. I guess we call it. Do we just do one job? It's probably easiest. Well, we'll do two, and we can swap them back and forth. We'll push right to the main branch. So we'll call it Rust cache action. All right, I don't trust my memory setting up a Github action. On, yep. So we need to run it on push to the main branch. On push. So we got some special stuff that we're doing here. We're only running it on pull request. We weren't running it on the main branch just because this spins up a whole bunch of boxes. So let's go to the main Tauri repo because we'll have something there. That is more typical. This is probably an easy one. Yeah, so this is what we want to do. We want to run it on push to the main branch. We're not going to do a matrix. We're going to do runs on. I was right. Runs on. Ubuntu latest, I think is what it's called. I don't know if the lowercase matters or not. And then we have the steps. So it's still building. So the idea here is that what we're trying to cache is, where does it say app? So this is the only thing that we're looking to skip caching, because this is the thing that is going to be rebuilt more often, likely. Your dependencies are going to change and that'll bust your cache, but that's going to happen much less often than your app changing. So if we can cache everything else except for the app, the idea is that we will be much more likely to share our cache. And speaking of, I just did a bunch of Rust builds. I don't think I put up the priority for OBS. Yeah, I'll do that on the side. Oof. This is the first stream on the new OBS too. So it seems like it's working pretty well. Performance-wise, I don't know if I really am noticing any differences, I guess, but so pretty simple app. We will do a release build, I guess. And I guess that's for the most part just going to be, we need to adjust the target directory. That's the big thing. Because our target directory is, they don't have something you can copy. Unfortunate. So I don't know what key and shared key are going to do for us here. Oh, so there's a working directory. I mean, I guess in our case, we kind of want to change the working directory. So Rust cache. And it's going to be SRC Tauri. So that should give us a cache there. We're going to run npm run. I guess I probably need to pull in Volta or something to pull in. Is Github Actions on node 16 or 14? I think it's on 14. So we'll probably want to pull in Volta because I would just rather use npm 16. We want to do npm run tauri build. That'll give us a release build. So Volta pin node at 16. And that actually does come with npm 8, but we'll just do, well, it's fine. We will just let it, whatever npm version comes with it. As long as it's version 8, it should be fine. And let's grab their, I guess just action. Yep. Drop that in there. So this will give us Rust on a stable toolchain with a minimal profile. I don't know that the minimal or the profile is going to matter much here. This is going to give us node 16. This is going to pull our code down in the default project structure, I guess is the best way to say it. This is going to do the cache, and this is going to run a build. This is basically going to no-op the first time. I'm guessing this is going to have both a run here and then a post. So the first time we run this, I think it's basically going to no-op. Then Tauri build's going to run, and then after Tauri build is done, Rust cache is going to have another step that does the caching. Like the follow-up cache, and then our run after that should hopefully have a cache hit. So I think we've got everything we need. So git ignoring the things we wanted to. We do not want because I don't care too much. Yeah. So we don't want no modules, we don't want our target directory, and we guess we kind of want the log file, yeah. We want our log file because that'll have our pin dependencies. And our log file from npm. I think we're good. Okay. Got code signing set up. I actually do punch my pen every time. I wish it would be a little bit faster, but you know, it's what it is. All right, so we should get a build. No jobs defined in jobs. This is why I was copying and pasting. Job. Which is jobs. Isn't it? Jobs. Yep. Line 13. Yep. Wait. Which that's it. I didn't indent them enough, so steps was not nested under. Steps needed indentation is not actually nested under the job. I really should double check, see if they have. They had a couple. Hey, there we go. They had a couple Github Action VS Code things, extensions. I think I tried them out when they first came out, but they had issues and I uninstalled it and I haven't gone back. Okay, so we're getting a Rust cache. Tauri not found. We need to do a there we go. Waiting for a runner. So we'll, yep, so no cache found. And you can see it's doing some keys already. So it's in this directory, which is where we want it. There's some paths that it's restoring. These are the keys. We can also give it another key. So it's running off of, you can see the Rust version's embedded in there as well. So if the Rust version changes, it's going to bust our cache. And this is going to take a little bit of time. So the other thing that I wanted to add in here quick was GitHub Actions has a concurrency, I think it is. So you can ensure that only a single job using the same concurrency group will run at a time. So the reason you would do this is for this situation. And this lets you, based on the ref, cancel all in progress jobs. that. And the reason this is valuable, if somebody strings together 2 or 3 commits, pushes them each separately, you can be triggering 3 CI builds. You potentially only, if you're doing some real heavy lifting, you potentially only care about the last one. So there's cases where you might want to actually leave this on because you want to see the outcome of each. But when we're doing this kind of stuff, where we've got these long builds, it's probably worthwhile to throw the concurrency on here. So we're getting through the compile. I think this took 4 minutes on my computer, so it's probably going to be similar-ish in CI. Because I'm doing other things while using the computer. And all this is doing is compiling right now. So I'm going to guess it's about the same-ish. 4-ish minutes. So the next thing we want to try is the concurrency. And then once we throw concurrency up there, we can... Now, is that just jobs, job ID concurrency? And you can specify it at the workflow level. So this whole workflow, this is neat too. When you click rerun, you could click rerun multiple times. That would cancel it. So I think this makes sense. Head ref. If you... Okay, so head ref is only defined on pull requests. Oh, it is unique and defined for the run. So maybe they do have separate run IDs now for multiple attempts. I think they used to keep the same ID. So if you have multiple workflows in the same repository, they must be unique across workflows. Oh, that's kind of nice. So that'll be based on the workflow file and then the git ref. So this is probably kind of what we're looking for here. So go ahead and put it at the workflow level. So now this will, if we do multiple pushes, it's going to cancel out. Let's see how this is going. We had an error. So Tauri requires on Ubuntu some additional dependencies which aren't actually in the runner. So we need to install them. And you can see here, there is that post step for the Rust cache. So that will be the thing that does the actually saving of the cache when it's a successful run. So to test this concurrency, I'm going to drop that in here. It's going to fail again. Add concurrency. It's going to spin up a job that's going to fail while that's running. Or yes, it's going to run for how long did it run? Okay, so I was right, about 4-ish minutes, which is I think about what it ran locally. So I ran a little bit faster locally here, 4 minutes versus 4.5. So this run is spinning up right now. It's going to fail, but as long as we push within the next couple minutes, it's actually going to get canceled first because this concurrency thing. So let's grab GitHub. Got a couple things now. I don't know that we need all of that for what we're testing here, because I don't really care about the indicator. So we can probably get away with a smaller amount. Not seeing it. That's okay though. Okay. Let's save this. Push it. It should cancel out our previous run due to the concurrency. Git commit. So it's still compiling. We're about 2 minutes into it. We should see this one actually get canceled, assuming this concurrency is working. There we go. Operation was canceled. So actually, we get a different indicator to designate that it was canceled, which is nice. So that'll be helpful on PR. We still could see how far it had gotten. Higher priority. So there's use cases. You might actually still want to run it every time. And I'm not sure if you can do logic as far as using concurrency or not, but that's a nice way to not just swamp your CI, which I've definitely done. You have enough of these running, throw a bunch of commits at it, and it spins up, the run 5 times X number of boxes. So you can blow out your CI limits pretty quick. All right. So while that's running, that should give us a cache, the Rust cache. So we can also start spinning up the cargo chef. I'm not going to cache anything that yet because I want to make sure I don't destroy my Rust action or my Rust cache action yet. So we're just going to grab this. We need all of this every time. We're also going to I suppose I can just take that out. We'll skip that for now. Also going to need to cargo install. I could potentially edit the dependencies. We're just gonna do it this way. We'll see where we get with it. Install command to help with cache. So this is running. When we push this, it's not going to be doing too much, so this should run pretty fast, but it's also going to trigger another build of this. And that is going to be a quick way to check our cache hit or not. And we can see the difference as far as how fast it's running. And I'm also curious, once we hit this post step, I'm curious what the size of this cache is going to be. Cargo install, cargo chef. think we could probably do a prepare right away. And this is potentially something that we could have run locally and actually save that to the repo. We would still need to be able to have a way to keep it in sync, but it's something to think about. So this is going to give us a JSON file that tells us if our dependencies have changed and caching around those. And you can see, so in this Tauri run, we are using the GitHub Action official, quote unquote official cache. And caching very similar things. So here we're doing the target. This is just general. So I think what we're going to end up doing here is, let's go ahead and stage that. I think we probably want to do this. We'll have a separate cache just for the registry, git and bin, and then we're going to have a cache for the target directory. This is going to be an src Tauri target. And what this is doing is it's hashing this. So assuming this other command, assuming this runs pretty quickly, we can actually hash on that instead. I don't know that we care about the cache name. Presuming that's mostly for posting the cache. Restore keys. So when you do a cache, you're giving it a key, and that key is the key for that cache. You can also restore from that. Restore from outdated cache for speed. So you can restore from basically related caches. I don't want this either. I don't want the current date. So this would be effectively, if we only care about just a cache in general, just having something, it's going to restore that. But I don't know how much we want to do that. And I'm not sure how this works across branches and PRs. So that's the thing that I don't know offhand. I know some of it, but run Tauri build. Why did we fail again? All right, what we're going to do instead is we got an action. I think it does it bring in. don't need to upload or anything. Upload artifacts. I mean, it still looks like we need some things. GTK. Is that actually up to date? Okay, it is 4. I did actually install them, right? So that's why it didn't work. It actually no opt. I'm going to switch to the action anyways. I don't think we're doing any, well, I don't think we're doing any caching, but I don't know offhand, so maybe I'll just leave it. Now, why did we no op? Oh, it's basing it off the matrix. We don't have a matrix here. Because we were only doing the one build. So if, I mean, this is only on Ubuntu, so we're just going to run it straight up. Just stage this first part so we can run that again. Always install WebKit. Yeah. All right, so fingers crossed that works this time. We want to do just these. I don't know if it's going to let me stage just. I think it's going to do that all block. Oh, it did actually. Okay. Because we don't want to bother with cache yet. And we don't actually want to run the build. So that should give us another run here. Oh, come on. Line 13 again. Yeah, line 13 is getting us. What's wrong with it? So if you open up the edit here, bad indentation. Okay, so it's not actually a line. The errors in I'm gonna have to undo that again. The errors in YAML files are not amazing because it's so reliant on the structure of the file. Which, unless you have something to check it locally, that your syntax is good, always ends up being an issue. Most of your PRs will look like this. Okay, so that's going to run. We are going to run. We got to redo this one again. Our next run. Let's make sure we actually indent this one so we don't get a bad file again. Run this. And then we're going to start caching it, and we'll see what it does. So our next can be this. Well, no, if we just do this, we need a build. So we need a build to have something to cache. And we want to restore them before. So we want to do this because we need this. We need the recipe. The recipe is going to be the thing that we are doing the hash on. I think that's probably. We're gonna try it. We're gonna try it. I've only ever really done my hash on the lock file. So we will see what this does. Okay, we're about a minute into it. Got a couple more minutes. We want to test this one out. So we got to do some more work with the actual cache itself, which is annoying. We could potentially split this out into a separate file. We can do a composite workflow that we just pull in and say, hey, cache the things, please. And then I'm curious how it's going to act across builds and such. Okay, I need to actually change this because it's not going to be matrix platform. Yeah, let's say Ubuntu latest. So we're strictly running it off of the key. Interesting. It's interesting that we have a dash at the end of that, but not here. I wonder if that's part of the reason some of our caches had issues. 2 minutes. So this is going to cache two pieces. It's going to cache the index plus the download in the cache cargo state. It's going to cache the target directory, which is in src tauri target. That's where the environment variable comes from. And there's also a cost to restoring the cache. So even if we're able to like completely cache this, if that cache gets really big, it's going to take some time to restore it too. So these big caches can take 30 seconds, a minute to restore. So if our build is taking 4.5 minutes, we need to have a build that takes maybe 30 seconds, a minute instead to like really make this cache worthwhile. Because as soon as you add a cache, there's some complexity. Assuming you can get it right perfectly all set up the first time and continue to keep it in a good state. Saving a minute or two here or there is nice. But caching is not easy. So you're going to have to deal with some maintenance there. And the overhead of saving a couple minutes may not be worth it. So this is got to be getting close to done here. What's the install for the... Okay, so the WebKit to GTK takes 30 seconds to install. And like this is something we could probably cache. because we're pretty much always going to need that for Ubuntu. And that is going to be unlikely to update enough that we need to worry about it too much. What's the update? Like if we just grabbed, I'm assuming that our Ubuntu instance is going to be reasonably up to date. Where is it? Come on. What are you doing? Apparently my future chat is... Oh, I'm getting cut off too. Glib. Caching isn't easy. That VC funded framework told me otherwise. Why isn't my future chat working? What is it doing? 6 minutes now. So it was taking 4.5 before because it was airing out before it had actually finished everything. So, I mean, if this ends up taking on the order of like 6 or 8 minutes or something, then it's probably worth having a cache in there. Come on. I don't know. Feature chat is not working. Yay. Yeah, so the having those dependencies cached might be worth that effort regardless. So even if you weren't doing this, uh, in general, if you're using this Rust cache and it's handling a bunch of this work for you, it's probably worthwhile to just chuck it in there. Is sort of what it feels like, particularly for Tauri projects, because there's a decent amount of dependencies here. All right, so our next run, we'll push this and we'll start doing a prepare for the next one. We should still get a cache hit here off of this. And we'll have this one prepped for the next where we start caching it effectively manually. Twiddle the thumbs. Where's that XKCD comic? I think about this one too much. 8 minutes. Oof. Yeah, it'll be nice to if we can kind of beat this workflow up a little bit to where we feel good about it working consistent and as expected, it would be nice to add this to documentation. If it's just a couple lines and you're doing effectively this and just dropping that in here, you know, after you're installing WebKit, that's a pretty big win, I think. Even if your cache is getting blown out and whatnot, we'll have to see how well it cache hits. What is? It's just spinning. let's just try closing it and reopening it while we're waiting. 10 minutes. Oof. All right. There we go. There we go. Much delayed, but I also bumped down the time. We went down to 5 seconds. It was at 10. That actually feels good. Hey, okay. Now we're nearing the end. App is usually, it's like the nearly the end. So we'll get a couple runtime things and then we should be good. Oh, it did runtime Rye already. So we're getting close. We're getting close. Is there anything else that we need to do with this? So we're running build. We could potentially have multiple caches. That's why I'm interested in this. So in create-tauri-app, we're spinning up a whole bunch of boxes. We could have a step up front that is doing this vanilla.js, and that's going to be sort of the canary in the coal mine, as it were. Like if the vanilla.js one works, the other ones should get much further. And if we can cache, if we can create a recipe JSON for that, and cache just the dependencies for that, those dependencies should carry through to all the other ones. And we kind of want to spin those up in multiple separate boxes because when we're generating a new Tauri app, we're bringing with it specific npm dependencies, and managing that state would be painful. So it's nicer just to spin up a bunch of boxes. But then we start talking, and this is where we start. Okay, bundling now. This is where we start running into issues with the repo level cache, because if you're needing to build for multiple targets, Windows, Ubuntu, Mac, potentially more in the future, build that cache pretty fast because you need to keep a cache for each OS. So like the only way you can reasonably rely on the cache within GitHub, I think, is if you're only building the dependencies. But even still, once you open up PRs, well, this is running. Let's double check on that real quick. So Rust, or no, GitHub Action cache. It might actually say in the action. Yeah. What's the action say about it? So it does use some compression. Add a best ever cleanup step to delete the archive after extraction to reduce storage space. And you can skip steps based on a cache, which is nice, but I don't know that we actually need it here. Cache keys, limits. So 10 gigabytes of caches. And it doesn't keep them around very long either. So like if this isn't something that you're going to be working on with a lot of commits, here we go. Now we're getting some cache. It's probably not even worth spending the time unless it's easy as just dropping something like this in. Oop. Like if it's literally just a line in your build script, it's probably worth it. Okay, cache size. It's actually not as big as I expected, which is just good. Whoop, where is it? And that's real nice that they spit that out. So now we should have, we got this lined up. This is going to add a cargo chef. Scaffold in cargo chef. I really need to hook that up to, kind of want to hook that up to 1Password. I just haven't gotten around to it yet. Okay, so this should give us a cache hit. Now we have 2 boxes. Cargo Chef is the new thing. It's going to do some stuff. This one should give us a cache hit. We skipped the update. I'm presuming that they're going to be keeping their boxes updated enough as far as security issues go. And I'm hoping just skipping the update it makes this run faster. It doesn't seem to actually make too much of a difference, so surprisingly. I guess not too surprisingly. If they keep their boxes up to date enough, it's going to no op mostly on the install or on the update. And this is the other thing. Like, we're going to have to cache the subcommand, which is why I'm kind of wondering. Well, I should move my cache up actually. So when we do the cache, we want the cache step to happen before we do any of the work. So we want to, we need the WebKit install, we need npm. I think we end up doing something like this. We need to have a cache step before we do any of our actual work. So this will pull from the cache if it's available. Otherwise it's going to no op. So this hash file thing, that's going to be interesting. I'm not sure how that's going to react to this. But if it's only doing dependencies, I'm not sure if it's going to like cache itself. That's the thing that I'm unsure of. Because that would be nice, because it's taking 2 minutes just to do Cargo Chef itself. Is this really taking 2 minutes now? There's no way. It didn't take 2 minutes last time, did it? 33 seconds. Is this an eventually consistent thing here? All right, so this actually gives us very little output. It didn't fail though, so that's good. Okay. Cache size. It's downloading it. Cache restore is 20 seconds. Not awful. Now we'll see how it improves our build time. And this will be our next push. We should still get the cache hit here. We're not going to be blowing out our cache yet. And if we've got on PR, we could build just the Ubuntu box. And when we push the main branch, we could build all of them. Like that might be a reasonable workflow. I'm kind of curious how long this is going to take. I mean, it says it's restoring a bunch of stuff. We didn't get the download stub, so we're definitely getting a cache from that. So the registry and index cache are good. And yeah, we're jumping right to bundle. I don't know that the bundling is super fast. And I don't know that there's going to be a way that we can reduce that as far as our GitHub Actions specifically goes. Maybe in the core, that's something that we can address. That would be something that we'd address in the core. But in our GitHub Action work here, it's not something we can improve, I don't think. But you can see that we went from, was it 11 and a half? The whole run took 15 minutes. 14-minute build with an 11-minute cargo run. 20-second cache hit, a minute for the actual build. So a minute 20 versus 11. That's a pretty big win just for dropping that line in. And like that cache is going to be much stickier. So let's see. We'll let this finish out. Still bundling, I think. And then we're going to drop this one in. Going to get an install. We're going to cache same stuff. It is going to be a different cache because our cache keys are going to be different from what the Rust cache action uses. So we're going to have two separate caches floating around. We're doing the state and then the target directory. And we are hashing it based off of this. So the follow-up run should have that. Or it should have a We need the file there to cache it though. Oh, well, no. So we need to install before we run it. We need to run it before we do our cache, otherwise it's not going to work. So like those have to happen together, right? So I guess we really do need them first. So we run cargo chef install. That'll take some time. Then we'll make the recipe JSON, and then we're going to cache. We'll restore if we can, but it will have already ran this. So this probably actually makes sense to do it based off of the lock file. Then at least we don't need to download it every time. So this is going to be the interesting part about this one, is that we have to have that subcommand. So unless we like make a binary of it or something, that we can just download the binary rather than having to compile it every time. Okay, so we went from a run that happens in 7 minutes down from a run that happens in 15, I think it was. 15, 20. Still not fast. The build happens much faster, but we're still stuck on bundling. So most of our time is bundling now. Which I'm actually curious if we can speed that up. That's something interesting that we could look into. Cache is up to date. So now we can push this, and we should get some more cache hits there, and then we should start seeing work happening in this new cargo chef. Run cargo chef. We'll see how this goes. I want to try getting a cache hit on cargo chef, and I think that's probably where we're going to end up calling it. See how this all runs out. I think we've tested the Rust cache action pretty well. We can get, if we're running everything, so specifically thinking Tauri apps here, if we're running everything, we're gonna have probably we'll say 3 gigabytes, 3.5. So you'll be able to get maybe 2 or 3 different caches in there. And I think it's gonna get a different one per PR. Oh, interesting. Using context to create cache keys. So it doesn't really say anything about PRs. Restrictions for accessing a cache. With V2, if you're using V1, you can only access the cache and workflow is triggered by a push or pull request. Okay, so you can pull it from any event, which is nice. You can access and restore in the current branch, the base branch, or the default branch. So, this is interesting. If we have a cache on the main branch, that's going to be generally pretty warm. So most PRs are, I think, can fall back to pulling that. Okay. So it can potentially have access to multiple caches, and it's going to use the cache that most closely matches its key, I believe. Okay, so this is what I was talking about before. We have a logical boundary between different branches. Cache created for the branch feature A with a base of main would not be accessible to a pull request for the branch feature B with a base of main. So you can't share the cache between PRs, but you can pull it from the main branch. And I think this is where it is particularly interesting using one of these two methods, because if you're only caching the dependencies, your cache hit is going to be much more likely when you open up a PR. If you're not tweaking dependencies, you're going to get a cache hit off of that main branch. You're going to be much more likely to get a cache hit off the main branch. And this is the fallback basically. So list of restore keys, you can partially match the cache and it'll still restore it. So we're doing something like this. And cache name, interesting. So it's going to restore. It would be able to restore from any of these, and it'll do the more. well, I think it runs through them in order, and that's why they tend to be more specific to more general. So it'll try to match on this. If it doesn't find it, it'll go to the next one. If it doesn't find it, it'll go to the next one. And this cache is much more likely to be warm from the main branch, I think. And if you're hashing off the lock file, I wonder how that's going to be. I think that's probably the other thing to try, is if you're just caching it directly. What time we got? It's probably something that I might try off stream, because this is going to take a little bit of a build. I'll probably drop results in this repo or something and just see what it looks like. But we're only caching the dependencies. If we cache everything and a PR, guess I'm hungry. If we open up a PR that's changing something like main.rs, it is going to recompile but it's pulling from the dependencies, including your app dependencies. So it will rebuild them. I'm curious what the actual difference is going to end up being. Like it's going to have to rebuild your app regardless, right? What does that process look like if your app exists and it needs to compute that and like flush it back out? I'm not sure. So I'll probably put in a matrix to test both of those and see what we can come up with, or put in another run that uses very similar, and run those caches against each other and see what that comes out to be. The plus side of just doing the dependencies is there's less that's actually caching. And the other interesting thing too is this Rust cache is so this is the other thing. If you have a log file, your versions are going to be a little bit stickier. I mean, I guess that's kind of an obvious statement, but if you have a log file, your dependencies are going to be less likely to change and bust your cache. And if you're caching just the dependencies, like this statement right here is I think the kicker here. The code that you're writing in Tauri versus the code that Tauri is bringing along, I think you're going to get a pretty high ratio. But I'm curious how effective it is versus just a straight cache. Like, what's the difference there? And it's doing some stripping of stuff. So when it does a build and then it does a cache, it's stripping out stuff that you don't need. And I'm curious how effective that is versus just doing this cache directly. So I'll probably smush a bunch of this together. Just do a straight cache, do a Rust cache, do a cargo chef, and do a cargo chef with Rust cache. I think it would be interesting to test all of those scenarios. This install though is, I think, going to affect things. So unless we can deal with that, this is sort of annoying. It being built in a way that I guess they've got an actual Docker image, so that's how they're not paying that cost. They've made a Docker image that has that. So I suppose we could do an actual cache for Cargo Chef too. Just always pull from the cache for Cargo Chef. That probably would be the way to do it, eh? But we'll see how this these steps go. So as expected, we had a state, no cache hit, and a target, no cache hit. Those should, after this is done, do a cache. So I guess while that's running, let's do one more. That is just a cache all the things, cache everything. So we're gonna copy this because it is going to be very similar to that instead of what we had in here. We still want to do this. We still want to do that. We want to do the state. We're skipping Cargo Chef. We still want to do the target and install and build. So this would be kind of the, I guess I would say the more the way I would see it more likely to be used when somebody's thinking about caching. This is probably the more common approach, I would guess. I'd assume that this workflow isn't used too much relative to other caching methods. What else? You can see a dependency graph now, can't we? Dependence. Okay. So a fair amount. Tokyo. Metrics. Hmm. So could very well be wrong about that. A lot of smaller ones though. Not that it's a bad thing. But I guess a bunch of it too is forks. So I'm presuming that this is a fork. Yep, fork. I wish there was a way to like filter out forks in this. Because like I care about things that depend on it. But if it's a fork, that's less of an actual, it's less likely that somebody chose to add that caching. They forked it and it existed. All right, we got to be coming to the end of this. So to install, this is 2 minutes. The other one was running in about 15 minutes, I think. So this step, I'm guessing, is gonna take 15. So we've got a little bit more time. Then we still need to test the cache. The downside of testing cache in CI runs is just watching the workflow. checking my make sure I don't have any notifications. So if we cache everything we want to do, I think this is good. We want to do the state and then we want to do the target. I think we could theoretically want to do this. These cache keys are going to hit now also, won't they? So this will be registry. And that's actually probably why they had that env in there, because it's easier just to change the env. Target. And this should be stable target, stable target, stable target, latest target. Okay, so that should give us separate, completely separate caches. I think I've actually I think I've completed these two. Stable target, stable target. And these should be registry. And these have the everything key in it. So that should give us a different cache than these. We actually want these two caches to be separate, which I think I've conflated them. So here you can see it caches the target. Only 500. Chef prepare. So I'm pretty sure I goofed that up. But I also need to cook, don't I? So let's push this. We'll get a cache hit, but I don't think it's going to be the cache hit that we're expecting. So I think we'll just push everything. We'll try a commit, try, cache everything. All right, so cache everything is going to take some time to build. This cargo chef, though, we need to make sure that we can do. So if we go into our create-tauri, I think we can do a cargo build here. Yes. So I think what we again skip frame. Doesn't seem like it's too bad. I see skip frames, but I think that might have been from before. Couple maybe. And I suppose I could have done our debug build since I was just testing. because most of those are done already. So we prepare the recipe. .json. That tells us if we can pull from the cache or not. I think we can do. I suppose I actually want to do the log file today. What did I? Oh, I did the toml for everything. Ugh. Okay, well, we'll change that later. That's not going to affect our tests. But we can kind of use it to, that change to test cache hits anyways. So rather than actually running a build here, we want to do this. I guess we need to do both. So we're going to have the whole downloaded cache. I think that's fine to keep separate. And we're going to have the target directory. Target directory is hashed based off the recipe JSON. This should be look at a past action. I think that should run pretty fast. It's the install that's going to take a little bit of time of that. Yeah. So like this happens real fast. So that's creating a thing that we can then decide if we want to pull from the cache or not. And if this matches, if a hash for this matches, we're going to pull the cache. And this is going to be, see, this is where it gets sticky because we want to do a Tauri build because we need those, the thing bundled. But we only want to be caching part of that target directory. So unless we're like stripping stuff out, that becomes pretty convoluted. So like to get this to work, the more I think about it, I think we actually need to split this into two runs. So like this would be like setup cache. And then we need to have like an actual build. And we need to do this every time. This is going to be, what's it depends on. Guess if, no, needs, it's needs, it needs this one to run first. So this one is going to set up the cache. We'll be caching the state based off of the, can switch it right here, cargo lock, since we're redoing a bunch of it anyways. Our cache chests are going to be bunk. This is going to be effectively running every time I think it's fine to keep it unrelated to this. Installing cargo chef. We'll have to think about seeing if we can cache that as a layer. This prepares the recipe.json, which is what we use to hash. That makes the actual cache, and then a post step for this caches it. So we can say post step for action / cache does the cache of the target dir created by chef prepare, which only includes the dependencies. And as always, I misspelled dependencies. This is why I have a spell checker in my IDE. Thanks for the follow, Ayushparal. Ayushparwal. Let me know if I said that right. Don't want to be disrespectful and mispronounce your name. Okay, so I think this will set up a cache. And then we can pull the cache after it's done. We still need to do this. We still need to do that, which is frustrating. Great, perfect. Glad to have you. Feel free to ask any questions. I think we're getting towards the end of the stream. We're just waiting for caches. We want to test some cache hits before we call it a day. So we've got, this should pretty much always hit a cache because it's going to be pulling from this. In which case that might run a little bit faster than a cargo chef prepare. So I guess we still need this because we need to decide if we're pulling from the cache or not, if we're going to restore that cache. And see, like this is where it starts to nice. This starts to, like, we're gating this on the fact of dependencies changing or not. But is it easier just to pull from the cache regardless? Like the first or the secondary checks are essentially just pulling from it regardless. So like, do we even care? We might be able to just skip doing this step completely. We'll see. But we don't need this anymore because we're not preparing. Now we need to run the full build. So I think this is actually what we should be looking at here. Oh, wait. Okay, we gotta try to cache everything. So this is running pretty good. We are getting quick builds here. Bundle still takes a little bit of time. And I think this is going to be pretty stable because we are this is a hash based on the dependencies. I'm not quite sure how that's calculated, but I'm pretty certain it's a hash based on the dependencies and or lock file. So I'll probably have to do another run or two to check these. I think we're about there. Don't know Rust yet. You're looking for streamers who are about to start something new. Are you interested in Rust specifically, or just in a project in general? Um, I have lately been streaming quite a bit on Tauri, which is an organization that I'm involved with, which is building this. So it's less of a small project. It involves quite a bit of Rust, but it's something that I've been streaming a fair amount on. I'll probably bounce to other topics too occasionally when new things come out and I want to experiment. But this will come up. This will come up often. We're getting pretty close to stable release. We just finished a security audit not too long ago, and have entered the release candidate stage. Okay, so cache everything finished. We are getting a full build. See, now that I ran a lot faster, were we actually going to cache it? Cache not found. Cache not found. I wonder why that ran so much faster. So it saved the cache. Because I think last time it took like 15 minutes. So the fact that it took 11 this time is pretty interesting. Yeah, I don't know. That's interesting. All right. Guess we kind of need to wait for this one to finish, which is just lovely. Just checking work messages. Generally try to stream about hour and a half ish. But this cache testing is taking a while. Okay. Okay, so it ran 11 minutes that time too. So what's this doing that? That must be running. So we'll say add second step to cargo chef cache. So hopefully we get some good cache hits on here. You can see here now that we've got cargo chef build depending on cargo chef setup cache. This one should be pretty consistently hitting cache, and I think this one should hit a cache too, and that should be a new hit. And then we'll see how the setup cache goes. And maybe one more push and we'll have some good info. So is there any programming languages that you're interested in? Is Rust sort of the one that you're has caught your attention. I've got a background in a few languages, but the bulk of my work right now is JavaScript and TypeScript. Rust has been a fun side thing and whatever I end up getting pulled into in the Tauri org. But for the most part, a lot of my effort in Tauri is around documentation and helping out on the JavaScript and TypeScript side. Because that's where we've needed the help. So I'll hopefully get involved in more of the Rust side of things. But okay, so cache. We hit a cache for the state, so we should not be getting a download, and we hit a cache for the target directory. So this npm run Tauri build should be going pretty quickly. And I'll be curious to see how they fare against each other. And we'll need to. I think if I get a good cache in this, I will test an adjustment on the main.rs, which should force a rebuild of at least that file. And I think that's probably going to be a good place to call it a day. Okay, so the cargo chef is still taking some time to install, which I think is going to make this one. We'll either have to figure out a way to cache that better. Like that might just get its own cache. Hi, buddy. Okay, so this made that. Ah, I copied the same thing. Bloody hell. It should be cook. It should be cook. So we've got the two commands. We got prepare and cook. I copy and pasted and forgot to change it. So now we should be doing cook instead. And we do want to build in release mode. So this should be that. So this will create a JSON file that has basically our, I'm assuming like our dependency tree, and that's going to tell us what has been compiled. So when we, or that'll be the basis for what we need to compile. So when we run cargo chef cook release, it's just going to compile those pieces. And then that will give us the assets that will be cached with this step and pulled back in here. I think we can go ahead and just have that other one cancel. We need to cook after prepare. Just sounds funny, but funny in a fun way. All right. So this one should get killed. So we have a concurrency. So if we push more than one build with a matching key for the concurrency, it will cancel the previous ones. So there you can see it canceled it. So both of these should be getting pretty good caches now. We'll want to cache this WebKit. And this is where I suppose if we can set up a good cache setup, that's potentially something that we could add as a composite action in the Tauri Action repo. So it's something that somebody could pull in and it would run. Like they could add it before their Tauri action, like the main Tauri action. Oh, interesting. So we didn't actually get any cache hits. So, oh, because it's putting it in the bin. Okay. Okay. So that'll save us some work there. Is there like a cargo add dash help? So we want to try to install, but we don't want to error if it is existing already. Oh, cargo install. No output. Require lock files up to date. Verbose. Build in debug mode. I don't want to force. Like I don't want to override it if it. That might. Oh wait, no. File system path to local. Never mind. If we do quiet, is it gonna no op? So cargo install, cargo add. Yeah. I don't want it to actually throw. I guess I can do it feels awkward, but if I do, where is it? Where are you? Oh, and I actually do want to make this consistent. I want to update on. Okay, no update, no update, no update. Just want to install. Because I don't want that step to fail. Like try to install it. It's going to fail in the next step if it actually didn't install correctly and it doesn't exist in the cache. Don't fail on existing cargo chef bin. We don't need it incredibly up to date. So the caching that we have going on and the busting that we have going on will be completely sufficient for just that command. Okay, so that got canceled. We should have a new one. Don't fail. That's running. Yeah, and if we can set up a composite action to do the cache, we can also cache this WebKit for those that need it, or for the boxes that need it. So you can do an if Ubuntu, add it, and if you add it, cache it. And we could put it on a different, it's like a completely separate key too. Okay, so this should have we pulled from some cache here. No, I guess, okay, so the other Rust cache action puts everything in a single cache. This is doing two separate caches. So our target directory is 500, plus our registry index and downloaded code adds another 2. So we've got about 700-ish. And if we look at the Rust cache action, our cache is about the same. Technically, the Rust cache action should have less, but the only real difference is going to be the compilation of our specific project, I think, which is probably not going to make that big of a difference as far as amount of cache goes. Okay, could not find cargo toml. That is fair. Could not find cargo toml in that, so we need to cook. So this should be working directory create-tauri. Chef cook. These will get killed again, which is fine. Hi, buddy. Yep. Got a kitty next to me. He's saying he wants to be pet. Yeah, this cargo chef is definitely more complex to set up. Which I think leads to, I mean, no matter what we do, we can't use Rust cache directly. Thanks for the follow. Kibar Pro? Thanks for the follow. Getting to the end of the stream, how my words are starting to smush together. Oh, come on. This one is giving us issues. All right. Failed to read recipe from the specified path. So we need to do that. We need to do that. Yeah, this is really giving us issues. Cargo lock, since we haven't gotten a good cache there yet anyways, we might as well change it. Let's fix these while we're at it. So cargo chef prepare needs to be that working directory. And recipe is going to be there. And this. I'm thinking next week we're probably not gonna do Tari stuff. We might have to add an extra stream. Um, I might actually find some time on Monday to stream. And I wanting to do some Raspberry Pi stuff. I don't know if I'll be able to get to Rust on Raspberry Pi, but that might be our Monday stream. That might be our Monday stream. Because that potentially might run a little bit longer, and that'll give us a little bit more time if I have extra time on Monday. The other thing that I've been wanting to do too is OBS just had an update, which is the program that I use. I think so. Oh, it did actually do that. Interesting. I thought they fixed it. That it actually doesn't do the infinite black hole thing. This had an update and it has a newer version of Chrome embedded into it. So we can pull in a browser source and do some interesting things with that, but we also get to use some newer functionality, web functionality. So I think I would kind of like to play around with that. Hook up some commands or whatnot to browser sources. All right, so what's our Rust cache action doing? Get an install, cache restore. Seems like we've definitely warmed things up because some of this seems to be going faster. We're getting a restore 500. And now we should be getting some caching here. So we get a really compiling app. That's interesting. Why did it compile just the app? So it's actually saying build the whole. No. Build dependencies. This is the Docker caching, the caching Docker layer. Then it does a full release build. So this feels weird to me that it. What's the do release here? Prepare. It feels odd that it only compiled the app. And that's what I'm confused about. We did have a successful cache restore. So that might be part of the reason. But I'm not certain why it did that. That feels odd. That feels odd. I'm definitely feeling like this cargo chef might be something that we need to use internally within Tari to do some more of the complex stuff. But it feels like Rust cache should just be like the default. We can set things up to where it pulls in this stuff easily, pulls in the Rust cache. We're using the Tari action. Like drop one thing in your Github Actions, and that's even something that we can spit out through create-tauri-app. And create-tauri-app is a way to spin up a project quickly. Go ahead and drop it in the chat for those that just tuned in. If we can set up the caching from directly, through that. When somebody runs it, they get a build set up in GitHub Actions if they elect to, and have caching come with it. I think that'd be pretty great. So we got to cache it here. That makes sense. We got to cache it there. And it's saying the cache size is 500 something. And it should be separate caches. It's possible that I had some other caches from other stuff sitting around. But this should give us latest Ubuntu latest registry. Oh, yep. Because everything's going to be a separate cache. Yeah, okay. So that's not too bad. We'll, to do the initial cache setup is coming on to 2 minutes. If we can cache out the WebKit build, it's still like 4 minutes. Both of these are running pretty well, and there's not too much difference between them. There we go. So that's finished. So and also 4 minutes. So all it's doing here is compiling the app. And if we look, well, the other one should just be compiling the app as well. And we're getting cache hits on all these. So if we do, now we'll change the main.rs. Well, I'll play around with that a little bit. We'll do just a change here. Kind of a nondescript change. Come on. Computer's ready to be done for the day, I think. Oh, it's doing a cargo check as well. Of course. Nondescript main.rs change. Holy. This Rust analyzer definitely does a number. All right, this is probably going to be the last run. Hopefully we get some cache hits. Rust cache action and cache everything. It kind of feels like they're pretty much the same. So like, I guess the Rust cache action is smaller. Like there's less going on there, so there's less. It's less likely that you have errors when setting it up, I think. But this cargo is chef. I mean, we'll get a bunch of cache hits on this the registry state and the bin, so that'll help. And I think those will stick around a little bit too. But it kind of feels like the Rust cache action seems to be pretty nice, but it doesn't seem to be making that big of a difference, which is Honestly, kind of surprising, I guess. I mean, if you're busting your cache based off of the lock file anyways, we're kind of just relying on the incremental compiler to like clean up for us there. So this is running pretty quick here. If we can get this cached, we're going to get this down to about 30 seconds. This seems real odd. But I mean, I guess if the cache exists already, like it doesn't need to be doing too much. Watching some builds, watching some builds. How's everybody's Friday going? I think we're definitely going to speed this up in the VOD. Caches are exploring what we can do with them, I think is good, and showing that is good. But there's only so much entertainment value. Hard balance to strike, I guess. Value versus kind of the level of engagement. Even if the content is valuable, if you don't keep people engaged, we'll see. Let me know if y'all like it or not. Can keep doing some more GitHub Action stuff. Otherwise, I suspect we'll do a little bit more Tauri things directly and front end kind of stuff coming up here. Because GitHub Actions is, you can do some cool things with it, but it's not a great stream thing. All right. This needs to finish. So we'll definitely want to see if we can get our bundling down. I wonder if there's any way we can speed that up. So once we start getting those cache hits, I guess if we can just run cargo build on a PR, maybe that's the, like if you're running just parts of this on a PR, like could you just run Chef Cook? I'm really, like, this just feels odd. Like something about that's odd to me. Because does it really have that good of a cache? I think what I'll end up doing is I'll bust the cache for everything. We'll put in a key to like straight up bust it. Once we get most of this set up, we can have a key that busts all of the caches. We can do a run with everything cached, or we can do a run with everything's like a fresh build, and then we can do another, basically rerun it, and all of those should be cache hits. Because I think we've got some like weird overlapping cache stuff going on here. Because this doesn't feels odd. All right. Well, I think we got a run that seems to have some reasonable cache hits here. So the cache action with cache hits is going to be running in about 4 minutes. I think we can cache this, so I'm just going to ignore the WebKit stuff. And we get about 3.5 just for caching everything. Which is odd. Why? I guess if it caches everything, we don't need to do... like, that's still taking 52 seconds. Because it's still doing the same stuff. 53 seconds. So 3.5. So like it must just be inconsistencies with doing the actual bundles. So I wonder if some of this is getting saved with the cache everything, which is not showing up when we cache just specific dependencies. And this one, we're going to ignore the WebKit thing again. So say 30 seconds, I guess. And three and a half. So this one takes about 4 minutes as well. So like it doesn't seem like Cargo Chef is actually gaining as much, even though our and like all of them don't seem to be actually gaining us that big of a difference. We are also being very specific on our cache hits. So in practice, we might be getting more cache hits off of cache rust, or rust cache rather. But they all seem to be pretty similar. Yeah. It does feel like something odd is going on with this, but I don't know. I'll probably by the time this video goes up on YouTube for the replay, if y'all are watching the replay, I'll update this with a couple more runs so you can check out what the runs are taking with cache bust and then what they're taking afterwards. But for the most part, it seems like just any caching is going to help. And unless this ends up being a more stable cache than what we have doing this, the only real difference seems to be the verbosity and putting it in. Like our GitHub action is much cleaner if we just have this in there. Or it's less verbose. Cleaner is, I guess, a kind of relative thing, but well, I think we learned some things. We'll push on it a little bit more. This is probably something we can, like I said, include as part of our just general Tauri action resources, so others can more easily get the benefit of caching, especially if they're using GitHub Actions. So yeah, we learned some things. We made some things. We ran a lot of builds. This was a long stream. Stay tuned next week. Probably two streams. So keep an eye out. So what did all the cool kids say? Hit that like button. Subscribe. All right. Happy Friday, everybody. Have a good weekend. Deuces.